So when we were talking about the distribution of water around the world, we're going to focus in a little bit right now on the United States, and then we'll come back to the rest of the world. Sorry. So one of the concerns that we have is how much water is falling in an area relative to the population. So in the last section, we looked at that distribution of potable water versus population around the world. But it's also, when you look within countries, especially a country the size of ours, it can be concerning for the distribution of people just within our country. And so if you look at this first one, we look at our annual precipitation. You can see the areas, obviously, we know it's drier here in the west. There's more water in the east part of the eastern part of the United States. But what we also look at is where are our big metropolitan areas, but where is our big food producing areas as well. And so where we have shortages, and we see that the shortages, there's a lot of these shortages that are falling in the Midwestern part of the United States. This is where a lot of our crops are grown. And also right in here, the San Joaquin Valley that I was just talking about, right in here. So these are areas where we do have that concern. This acute shortage, obviously, this is our desert west, where we tend to have water shortages all the time. It's just when we start to get these larger metropolitan areas into the mix, it becomes a bit more of a concern because now we have not only food that we have to grow, but we also have people that need water as well. So when we look at our fresh water here in the United States, we talk about how all these areas here, right, got all these states here in the West that could be in conflict over fresh water. And so when we look at areas where we don't have those water needs that are being met, there are some areas, especially up in this blue here, up in Arizona, where I'll make this a little bit bigger. Um, this blue area up in here, there's a lot of Indian reservation that's up in there, and they actually truck their water to people because they have no wells, they have no water systems. So we're talking about those unmet rural water needs. We're talking about they have no water in some of these areas unless it's trucked in to them. So some things that we to kind of consider. So when we look at, and those are areas that are going to tend to be higher conflict areas. Right here, this is the Colorado River as it comes down in between Arizona and California. We get a lot of our water from there. California gets a lot of their water there from uh, for agricultural reasons, and then also because the Colorado River goes right down into Mexico. You got the Rio Grande with the same kind of issues. We have such a highly growing population that it's not surprising that so much of our population lives in river basins that don't have enough fresh water. So when that kind of thing happens, we'll talk a little bit about some of the actual consequences that happen there. But just to think about here in the Phoenix area, um, there used to be water that ran in a lot of our streams that are now dry most of the time and only have water in them during floods, during flash floods, or during the monsoon. They used to have water in them all the time. So this isn't just happening in other parts of the world; it's happening here as well. When you look at lakes and seas shrinking, we're talking usually about natural lakes. You can see the fluctuations in our lake levels. If you go out to a lake, you can see the bathtub ring, we call it, where that the line is where you can see where the highest water levels have been. Um, our falling water tables, we have some areas where wells are going dry because they're not down far enough in the ground in order to get to the water anymore because they're being pumped so much. And we'll talk about the Ogallala Aquifer in particular, which is in the Midwestern United States. We have a lot of areas in the world that have stress on their river basins. You can see it's not just us, even though it's pretty concerning that when you get into these orange and reds, these are higher levels of stress, and that's the majority of the United States. Pretty much from the Mississippi River west, you're looking at higher areas of stress. But then you look at, these are all agricultural areas here in Europe, not so much here in Africa, but over here in Europe. And then you just have desert areas, which become real stressful. And then you look at not only you got higher populations, and then you look at the conflict just that we talked about at the beginning with political conflict. So there has to be those agreements between farms and cities. Who's going to be getting the water? Where do the priorities lie? We actually here in the Phoenix area, we bank some of the water that comes down the salt. So water from the salt and water from the Verde rivers both meet. So if you go like to Saguaro Lake, Roosevelt Lake, that's on the Salt. Horseshoe and Bartlett are on the Verde. And so the water from both of those, the Verde actually joins up with the Salt, which joins up with the Gila. And down around Gila Bend, they actually have areas where they flood. They dam the river, they back it up, they flood. They only let through the amount of water that we have to let go through, per our agreement with Mexico. And then the rest of it, they actually bank it, so they let it soak down into the aquifer, for later on for use for agricultural reasons. Um, Most of our crops that we grow are very water. They use a lot of water, and so excuse me, it's really essential that we have those agreements and those understandings about how are we going to get more water, or how are we going to conserve more water, and so that we have more available for use. So our aquifers are underground storage areas, essentially. And when you think about the underground storage in an aquifer, it's not like necessarily a giant puddle underground. It is like that in some areas, but in most areas, it's actually the water is trapped in between the dirt and the rock particles that are in there. It's not like a giant underground lake. Um, so when we think about that, it's you drill for it still like you drill for a well. Groundwater is getting pulled out of the ground faster than it can be replenished. It takes a long time for water to seep down into the aquifer. A lot of times, especially in lower areas like this, the water is actually coming from higher areas, so it's actually traveling underground, with the slope, sort of like surface water does. Water does travel underground as well. Um, Most of that water is being pulled out for irrigation, and so we're growing crops that tend to be thirsty crops in areas where they don't get a lot of rain, and so they can't do dry farming. They can't rely just on the weather, and so they have to pump. So in this side, it's talking about India, but we're having similar problems here in the United States as well. So while there's great things about using groundwater, is that it's always there. We don't have to wait for it to rain. There's groundwater most places. It just depends on the rock substrate, what's underneath the ground in there. And if we pump it slowly, then it's renewable. But if we overpump it, then it's not renewable. Um, you don't lose water to evaporation, which is what we lose a lot of water to our surface water here in our lakes and things like that. We lose a lot of that to evaporation. Um, but when we pump out too much, we can have some subsidence, and we'll look at in just a second some of the consequences of overpumping. And when they're polluted, it's polluted like that for a long time. We're going to talk about water quality, especially here in the Phoenix area, and why you can't have wells in the greater Phoenix area. We'll look a little bit about what saltwater intrusion is, and it does reduce the water surface flow, because if you lower the water table, then more of the surface water is going to soak in. So you're going to have less available for surface water. So the Ogallala Aquifer is, first of all, that's like my favorite word in the entire world to say. I don't know why, it just is one of those things. But it's the biggest largest aquifer, and it covers most of the Midwestern United States. So when you think about all the agriculture that happens in the United States, you're looking at a little bit bigger area than what the Ogallala covers, but this covers a great deal of it. And so that's where a lot of our water comes from. So when we look at um, the consequences of overdrafting or taking out too much water from those particular areas, one of those consequences is going to be that eventually we're going to run out, and we're not going to be able to support our crops that way. Um, After this video, there is going to be a short video about looking at the Ogallala in particular and talking about its geology. So I do want you to watch that. This one here is just showing a change in thickness of the aquifer, of how much water was available. And so these darker orange and red colors are showing greater differences. So these are at the really highly over pumped areas. Like I said, it's not one giant lake, so they're like pockets of water in here. You can see areas, so in the lighter blue like this is areas where it wasn't overdrawn as much. But you're still looking at some significant changes in thickness. So one of the things that can happen when we overpump is um, saltwater intrusion. And I'm going to move it to this other side so it's a little bit bigger. But so basically what's happening here is that when we pump, you have what's called, first of all, you have a zone of saturation, which is what this area is here. So you have the water table is the top of the zone of saturation, and that's just where all the air pockets are filled in with water. And so that's where we try to drill our well into is down below the zone of saturation so that you can pump water. And as long as you're pumping um, at a normal rate, that water level is going to stay up. Now, when you get near the ocean, what they're showing here is that there's an area where the pressure, that's why it's showing these arrows going either way, the pressure of the fresh water keeps the salt water out of those air pockets in the soil. But if we start to pull out too much of the fresh water, then it's not there anymore to keep it out, and that's when you start to get saltwater intrusion into your wells. And then obviously that water is not usable. So that would be one side effect of areas. So it can either be that the well was too close to the ocean or that it was pumping too much water. Some other side effects can be sinkholes or subsidence is what this is called. So the water, I'm going to go back to this slide for just 1 second. Not only does the water fill in, when it fills in all those spaces, keep out the salt water, it also takes up space. And so when you take out the water that's in the spaces, then there's nothing holding up those spaces anymore. And when you have you're pumping out down here, and then there's nothing holding up. So you're taking out what was holding up basically up here. Not everything, because once again it's the air pockets, but it's not holding up as much as it was anymore. And that's when you can get sinkholes that'll happen because you end up with you've had that kind of thin layer that was on top and it gets too heavy. Now, some places where we have what's called karst topography, which is an area that was a lot of limestone, as the water comes and filters down through the top layers of the soil and it gets down into that limestone, the water will actually eat away. It'll pull the calcium carbonate out of the limestone and it'll make air pockets. And that's where we get caves, things like that. And so in areas where you see like this giant sinkhole like this actually was an underground cavern that the water had actually pulled away and all the calcium carbonate or a lot of the calcium carbonate and it made giant pockets underneath and then the top level was too heavy and it collapsed down. One of the good signs of it being an area with karst topography is the color of the sediments that are in here. If you see how light colored they are in here, that's a good indication that it's limestone because a lot of limestone is that light colored rock. In looking at other areas of the world, here's in Saudi Arabia. So this was a map showing groundwater pumping. So in areas, and we're looking at this picture on the left here is 1986, 2004. So you can see that the green dots are all the irrigation systems, and it's crazy how many more there were. Look at there was just a few up here. Okay, in 1986, and then in 2004, they're all over the place, and the brown dots are the ones that have already gone dry. So during that time frame, you're looking at 18 years. You already went from having no wells in this area to having wells and they've already drained. So that tells you that they're over pumping and that they're not able to recharge or to renew themselves at the rate at which they're being pumped. So what do we do about our groundwater problem? Well, first of all, is if we look at conservation as a resource as opposed to as losing a resource. So if we use less, then we have more available to us. If I use less money, then I have more money later on, right? So it's the same thing with water. If I use less water now, then I'm going to have more water later, especially if it's in the ground, it's not going anywhere. It's going to stay there. So looking at how do we conserve the amount of water that we have and then try to limit the use of it. And that's basically what this banning the new wells are and buying and retiring. We're trying to limit those use. And then when we look at that using less water, that also goes along with what are we planting. So if we plant crops that don't need as much water, then we're not going to use as much water. So that would be on the side of more of our front of the pipe of trying to take care of the problem. And then on the other side of it, this is a little more like the stick, I guess you could say, the regulation side of things, where we say, okay, if you're going to use that much water, then we're going to raise your water rate. And so we're going to raise your water rate 200%. So you're going to have to pay a lot more for any of that water.